Okay, so we're looking at lecture 23, and we are looking at graphing quadratics. So, what can you tell me about quadratics? Yes?
They have a parabola.
Their shape is a parabola. So we graph them, they're definitely a parabola. Let's look at one. Let's give an example. Let's, what color paper would you like?
Blue.
Okay. And we need grid paper, right? Grid paper. Okay, very good. So let's go ahead and look at a parabola. So number one, if you're doing Roman numerals, that's fine. I think mine are just basic numbers. Number one. So let's look at a parabola and realize that parabolas can be anywhere on an axis. We're just going to look at a parent function. So 0, 0, 1, 1, 2, 4, 3, 9. These are very basic parabola. All right. What are the characteristics of the parabola?
Up and down.
Explain.
Crosses the y-axis.
It has a maximum.
Has absolute minimum.
This one
Or
has an
minimum,
absolute
whoops.
minimum.
That's
But
what I
they
meant.
could have-
Okay. What'd you say?
But they could have mid or left.
They could have a absolute maximum if they were the other direction. Something like that, right? So I have a question for you. Can a parabola look like that?
No.
I don't know.
Well, it can be straight sideways.
A parabola can be straight sideways. So you're telling me a parabola can look like this.
But technically, it wouldn't be a function.
Say it again.
It technically would be a function.
It wouldn't be a function because it fails a vertical line test, and that's actually half of a hyperbola, which we'll cover in conics if we get to that. So no, a parabola has to only be going up and down. In fact, we have names for those shapes. We'll talk about that in a little bit. What else can you tell me about it? So it has a maximum, it has a vertex. You can go up or down. What else can you tell me about a parabola?
Is axis of symmetry something like vertex?
It does. No, it's something different. So number one, we actually have what's called an axis of symmetry. Okay, so an axis of symmetry, and that's going to go right down the middle. In fact, we could actually say a quadratic is split in two. Now, you said the vertex and the axis of symmetry are the same thing. Well, the vertex is always going to be on the axis of symmetry. Okay, but they are two different things. So, what can you tell me about the axis of symmetry? What does symmetry mean?
Same on both sides.
It reflects on both sides. So whatever it does on one side, it looks exactly the same on the other. Okay, so in this case, we have the axis of symmetry. So we're going to look at the form here. Okay, so with axis of symmetry, we have different forms of the equation. And the form we want to look at here is called the vertex form. Those of you from Algebra 2 that have me from Algebra 2, we talked about vertex and factored and standard form. We're talking about those three again today. The first one is vertex form. And that it gives us our axis of symmetry. This is actually the best one if we're going to graph the function. When it comes to vertex form, this works best to graph the quadratic function. So this is going to look like this. F of x is going to be equal to a times x minus, and we're just using letters to represent certain parts of it, right? Do you guys remember the letters we use in vertex form?
So like K and H.
Very good. So x minus h squared plus k. Ooh, that's really ugly h. X minus h squared. Okay, so this is vertex form. So what does each part tell me? What does the h tell me? What's the h tell me?
Height.
Good guess, no.
That's what I was listening to.
It's actually kind of the opposite.
Width.
Do you remember?
I'm thinking.
You're thinking.
Yeah.
Okay, what do you think now? What'd you say? You said the width? No. Good thought, though. Okay, this is what we call the horizontal, which is maybe why they use the letter H. Okay, it's the horizontal shift. Okay, so horizontal means left to right. Left and right. Shift means it moves it. Okay? So the H tells us which way it goes left to right. Now, what's true about inside parentheses?
They switch it, they go out.
Switch the direction. So if this said x minus 3, you'd actually shift it which way?
To the right.
X plus.
3 to the right. 3 positive. If it said x plus 3, you would move it to the left. When it's inside the exponent, when it's inside the parentheses, you always do the opposite of what it says. And that's true for every function. Okay? If it's inside that thing with the x, inside that function with the x, you always do the opposite of it. Okay? Hopefully we have our phones put away, we're not looking at them. So what is the k then?
Vertical Y.
Say it again.
I'll say the vertical
The-
shift.
like-
Vertical shift. There you go. That's the words I was looking for. Vertical shift. So we always start at 0, 0. So if we put in something like, let's go, I don't like this blue, let's go with a darker blue. So let's say I give you f of x equals, and we'll just pretend the a is not there right now, x minus 4 squared plus 2. It's going to take that parent graph that starts at 0, 0, and it's going to move that vertex where?
Up to, and then
Up to.
over
Up
to the right,
and
to
the right.
4.
To the right 4, 1, 2, 3, 4, and up 2. And this right here is actually my vertex, 4, 2. And now we see why it's called vertex form. Because by looking at the function, doing nothing to it, I can tell exactly what the vertex is. So the vertex is going to be right there.
So it always starts at 0, 0?
Well, this tells you where to shift from 0, 0.
But like when you're starting it off, it always starts at 0, 0, then you move it whatever the function says.
Correct. Yeah, this is actually an ordered pair. 4, 2, that's where the vertex is. Yeah, you think about shifting if you want, but just that's the vertex. That's where you start. 4, 2.
And then if it's x plus 4, you go to the left, right?
Correct.
It's a negative?
Uh-huh.
Okay.
Because you always do the opposite inside the place. Okay. Now, the one thing we have left off is the A. What does the A do for us?
Isn't that
Like
like
compressive
or stretch or you're stretching something?
Yes, this is the stretch or compression. The stretch or compression.
Teachers, please excuse the interruption. At this time, we need juniors with last name A through M. Again, we need juniors only at this time with the last names A as in Apple, M as in Mary. Thank you.
Do we have to go
Oh, that's really nervous.
Where are you guys going?
Brandon?
down
It's-
to the foyer or whatever?
Oh, it's
Yeah.
that symposium.
They go down to the front foyer, they walk,
See you guys.
you guys walk
I mean-
around, ask the people questions about businesses and all that.
Can you buy stuff?
They have a raffle going on, there's like a small
Is there
box
food?
of chocolates.
Don't get them.
They have candies.
Don't
Hey,
get them.
bring
Don't.
me back candy.
Huh?
Bring me candy back.
Yeah.
Ready to go?
Don't get them up.
There's a
I don't wanna miss that
raffle.
stuff.
It's like
I'm
one of
recording,
those.
so-
Huh?
I'm recording.
Oh, no, I don't like Bring me chocolate.
It's your call.
Yeah, it's one of
Where are you
those
going?
where
Bring me chocolate.
you guess how many things are in a jar. There's chocolate.
Okay, bring me chocolate. It could affect your grade.
Oh
Okay.
my god.
Okay.
Only negatively, because if you don't bring me chocolate.
Oh.
Have a good time. All right, so what does the A tell? It's the stretch or compression, right? So if you remember from a basic quadratic function, those of you that were with me in Algebra 2, which right now is only 2 of you, I don't know how the other ones were taught, but if I'm going to build a quadratic, here's my vertex, how do I find the next point? Because we know it's the U shape, how do I find the next point?
Isn't it like,
It's over 1 and
Two.
up 1.
yeah, and then
Over 1, up 1. How do I find the next point?
and then over 1 up 3,
Over 1, up 1, 2, 3.
and then it just reflected.
Then over 1, up
5,
5, 1, 2, I'm off the graph.
and then it's like,
Over 1, up 1, 2, 3, 4. And it goes by odds, right? Then over 1, up 7, over 1, up 9, and so forth. Okay? And then, of course, I reflect it. Over 1, up 1, over 1, up 3, over 1, up 5. I just counted 1, 2, 3, 4. No, there it is, 5. So then you have your parabola right in there. Okay? Well, the A changes that. Okay, so we have that parent function, that nice cool parabola, typical parabola. The a then stretches it and changes it. So what we do is, let's say we have, let me get rid of that, and rather than doing the 1, 1, 1, 3 and all that, let's give it a different a. Okay, what a should we give it?
4.
Oh my heavens, let's not
Two.
do 4, let's just do 2. Let's just do 2. Because if I give 4, I'm gonna be way off the graph really fast, because it's gonna be very narrow. Let's go with 2. So what happens with 2 is, rather than going over 1, because normally I would go over 1 and up 1, right? Well, I take this value, this up value, and I multiply it by a. Okay? So I'm always gonna go over 1, but now I'm gonna go up 2. Because normally it would be 1, 1, now it's up 2. Now the next one's normally over 1 up 3,
Or 1 up 6.
now it's over 1 up 6. Over 1 up 1, 2, 3, 4, 5, 6. And then I reflect that, and that gives me the shape of my parabola, which is narrower than the parent.
I thought it would become wider.
It becomes narrow. The bigger the number from 0, the narrower it gets.
So
'Cause
what
if
would
it's-
it was negative?
Say it again?
What would be if it was negative?
Well, if it's negative, it goes down, but the same thing, the farther away it gets from 0, the narrower it gets. Okay? So the closer you get to 0, the flatter and the wider it gets.
Yeah.
All right, so that's what the A means, the H and the K, okay? So let's graph this one real quick. Let's give you a try, give you a shot at this one. Let's give you example for number 1. Let's give you f of x equals, let's actually do a negative. Let's do negative 3 x plus 2 squared plus 5. Jot that one down. And then let's do a quick sketch. Okay, first things first. Let's go switch colors. What's the vertex?
Negative 2 and 5.
Negative 2, 5. So you're going to go negative 2, 1, 2, 3, 4, 5. There's your vertex. Easy to find, right? You good with that? You good? Now, normally, I would go from my point here, I would go over 1 and up 1, right? But now I'm going to go over 1 and do what?
Down.
Down 3.
How far?
3.
Because 1 times negative 3 is now negative 3. So I'm going to go over 1 and down 3. Then I can reflect that. The other one, the next one should be over 1 and up 3, right? Now it's going to be over 1 and down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then reflect that. And there's your parabola. Kind of a skinny looking thing. Okay? Okay, we good? Questions? Need another example? Move on. So, first form was vertex form, right? All right, number 2. Okay, now we said the first form is good for what?
Axis of symmetry.
Axis of symmetry and graphing, right? Because you can find the axis of symmetry, you can find the vertex, it's easy to graph. Okay? The second form is what we call standard. And we all know standard form, right? F of x equals what? Just do a test over it. Standard form of a quadratic.
A squared plus b x plus.
X squared plus cx plus c. Very good. Okay. Now, you guys remember the quadratic formula, right? X equals negative b plus or minus the square root b squared minus 4ac all over 2a, right? Okay. Now, what was this? What was the name we called that?
Discriminant.
This is a discriminant. It was one of the questions, like the question number 3. What's the discriminant? B squared minus 4ac. 2 real, 2 complex, 1 real, right? So what's the rest of it? What's that? Well, that, my dear class, negative b over 2a is the axis of symmetry. Last time I'm going to write that, I'm going to write ALS from now on, with the axis of symmetry, negative b over 2a. Okay? So if I want to find that axis of symmetry, I just do negative b over 2a. Yes?
So you don't have to do anything else, you just do negative 0 to
Negative b over 2a. That's the axis of symmetry. That's the formula for it. So if I give you something like, let's say, hypothetically, I give you f of x equals, let me just pull one randomly out of my notes that I already have worked out, x squared plus 8x plus 9. And I'm not asking you to solve this one, I'm asking you to graph this one. The first thing I have to find is the axis of symmetry. Okay, so where is the axis of symmetry? Well, what's b?
4. Oh, sorry. 8.
Negative.
Negative 8 over 2 times what's a?
1.
1. So I get negative 8 over 2. So my axis of symmetry is at negative 4. Okay?
Jumped the gun, sorry.
Say what?
Sorry, jumped the gun, sorry.
You're good. I'm glad you're ahead of me. That's good. Now, so the question then is, what am I going to look for next?
The,
Vertex?
I'm going to look for the vertex. So I have the axis of symmetry, which happens to be what part of the vertex?
the point,
Which point?
the middle.
No?
Min or max?
Of the vertex, it's going to be the x or the y.
X.
It's going to be the x. So if I ask you for the vertex, the first thing you find is that axis of symmetry. That's the x value. Those are the same. Okay? How do I find the y value? This would be the minimum. If it occurs at negative 4, the question is where's it at? Where's the actual minimum at? How would I find it?
Isn't it just the 9 in standard form?
Say it again?
Isn't it just 9 in standard form? for
Not,
the y? No?
unfortunately. That's the y-intercept.
Oh, okay.
Well, if x is negative 4, and I know that x squared plus 8x plus 9 equals f of x, what do I do?
Plug. No. I was
Plug.
like plug negative 4 for x.
Yes.
Oh.
I simply go up here and I say, okay, what's negative 4 squared plus 8 times negative 4 plus 9. And you just plug it in. Now I have 16 minus 32 plus 9 gives me what value? Oh, good, I'm right. Negative 7. Okay. Now, does that make sense? Negative b over 2a, plug it back in, you get your vertex. Now, if I were to ask you, and this is a test question, write the function in vertex form. Because vertex form is easier to graph, so let's write it in vertex form. Okay, so f of x is going to be equal to, what's a in this case?
I think for
What's in front of the x squared?
1.
1.
So,
So a will be the same through every different form of the equation. So it's just going to be 1, if you want to put it there, times x minus what? Say it again.
X wouldn't be x plus, yeah.
Yeah, it'd be x plus 4 because it's x minus the negative. So x plus 4 squared, and then minus that. And now we've just translated it. Once we found the vertex, we just translated it into vertex form.
Do we have to put the 1 in front of the x plus 4 squared?
You don't. I just did it to show you, hey, this is what a, and it doesn't matter. If this was 3 or something, you would just bring it down here. It's always going to be the same. I didn't mean to hit the x.
I don't know if I'm getting ahead here, but are you gonna like give us one that's actually that wouldn't make sense. For like
I'm going to give you what?
one that's like hard to divide by. So like if that was 8 divided by 3, or like you had
Then you just have 8 thirds.
you just 8 thirds.
Yeah. I hate to say this, but with college algebra, you're going to have to deal with fractions. Fractions are our friends. We like fractions.
No, we don't.
Lyrica
We don't.
loves fractions. In fact, she wishes everything was in fractions. Right? Can I get an amen? Amen. Thank you. I heard that.
I don't like fractions.
I hate fractions.
Just telling them one more time. You hated
I
that.
want a whole number.
Okay, let's see here. So we converted standard to vertex. We've graphed using vertex form. We need to go any of that. Are we good? You good with that? Yes?
Yes.
Mhm.
Beautiful. Okay, so let's have you try one then. You're excited, aren't you? Let's try one. Okay, this is you. You try. You try. So I want you to do two things. Number one, I want you to convert to vertex form. And in letter B, number two, I want you to graph. Now, understand when I say graph, I mean sketch. Okay, it needs to be pretty close to what we're looking for. I understand you're doing paper and pencil. Some of you don't have grid lines, so just make it close. Okay? So your function is this: f of x equals, let's see here. Let's pull one randomly off the top of my head. How about, 4x squared minus 16x plus 3. And your vertex does not involve fractions, Lyrica, I'm sorry. Next one we'll do fractions. This one should be integers.
It's okay.
Okay, vertex form, and then sketch me a quick graph of it.
So you want us to rewrite it in vertex form?
Say it again.
Yeah.
Rewrite it into vertex form. Yeah. Then we have two more things to look at. How are we on here?
Third.
Brennan, you were on my list
For what?
for this Ignite thing,
Amelia
being an
replaced him.
ambassador or something.
What the heck is that?
Amelia replaced him.
Who did?
You were supposed to show around the 8th grade.
Oh, yeah, I wasn't gonna do that.
That would be a scary thought.
That's where Ada is.
Yeah, last year was really bad.
It was.
Yeah, it was bad. Wait, so the axis of symmetry is the x, right?
Correct.
Okay.
Yes. So when you have the vertex x, y, that is your axis of symmetry. Those are the same things. How we doing? Need more time? Yes? Excuse me. I got you. Keep working.
I don't know what to do.
Or is it?
That doesn't look right to me.
Yeah, it didn't look right to me.
Yes. We'll find out in a minute. Okay, you guys ready to look at this one? You what? Okay. We'll give you another 30 seconds. Go. Inside. Did you get the same answer?
No.
Okay.
Kind of. A little bit
I mean, kinda.
around there. Around the corner.
You know, it's either a yes or a no, right?
Something with this, you know, cut out for this.
Oh, because I put, it was supposed to be this. Right? It is already 16.
All right, let's find the vertex.
Oh, because it's a positive.
How do I find the vertex?
Negative b over 2a.
Negative b over 2a. So negative b is going to be a negative 16
So
over 2
Oh,
times
no, wouldn't it be positive?
4.
Yeah, it's fine.
2 negatives make a positive, yeah. So we end up with 16 over 8. You should get an axis of symmetry of 2. So my first point is going to be 2.
I got that.
You got that? Jordan got that?
That's as far as I know.
You guys got 2? Yes. All right, now what do I do with the 2?
You plug it in.
Plug it in. So we have f of 2. This is step B, if you will. So that's going to give me 4 times 2 squared minus 16 times 2 plus 3. Okay, so let's see. What's 4 times 2 squared?
16.
2 squared is 4 times 4 is 16 minus,
32.
which is negative 16 plus 3,
Negative 13.
which is negative 13. And there's your vertex. Okay? Which means then, when I convert it to vertex form, I'm going to write the equation f of x is going to be equal to, what's a?
4.
4 times the quantity
X minus 2 squared.
x minus 2 squared
Minus 13.
minus 13.
Oh,
There's my vertex form. Okay? All right, you good with that? Both of you? Okay. You good with that? 'Cause that's what you got, right? And how did you sort of maybe kind of get it right?
She had just put negative 2 because she forgot that when you had 2 negatives for 16, it becomes a positive.
I went wrong.
Careful. I will tell you that mistake was made over and over and over on the test. A lot of times people would write 2 negatives and they'd write a negative, and I'm like, 2 negatives make a positive. What'd you say?
Oh, I went wrong because I went 4 times 2 and then I 8 squared, so.
Yeah, order of operations, that's a common mistake too. Okay, be careful, be careful, be careful. Okay, so we got our point. Now, then part B says to graph it. Okay, so with your permission, even without your permission, I'm still gonna erase all this.
That's rude.
Next hour I'm gonna do, or next time when I teach this today, I'll not erase it and I'll keep these notes, but for today I'm gonna erase it. So I'm gonna graph it, right? So I start here on my graph. It's gonna be way down to the negative, so I'm gonna go here. Okay? So where do I start?
2 and negative 13.
So I'm gonna go over 2, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hang on.
On the graph.
13 right here. Way on there. Bam, there we go. Okay? Now here's the new part for some of you, old for some of you, right? I'm supposed to go over 1 and up 1. But in this case, because my A is 4, what am I gonna do?
Over 1 up 4.
Over 1 up 4. So over 1 up 1, 2, 3, 4. And of course reflect it. Now from this point, I should go over 1 and up 3, but what am I gonna do?
Over 1 up 12.
Over 1 up 12. Over 1 up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Oh my goodness. And then right there. Bam. Bam. There we go. And just on a little side note, Lucas, this is for you, because you asked earlier. Notice this number by itself is 3. That is the y-intercept. So it crosses the y-axis. So you always check as you're doing your counting that those have to match. Okay? All right, very good. You got that down?
Yeah.
Tell me that you're 30. Did I ask that
Yes,
already?
30.
30. Okay. Really, there's a couple more things we need to go over. We looked at converting. We went from standard form to vertex, right? What about the other way around? What if I want to go from vertex to standard? Because remember, what's vertex good for?
Graphic.
Graphic. What's standard good for?
Solving.
Say it again.
Solving.
Solving. That's what we just took a test over. Solving using quadratic formula, solving using getting what x equals. Okay, solving to find those x-intercepts. So sometimes we want to go to standard. So if I give it to you in vertex form, let's give you something easy like x minus 2 squared plus 1. How would I put that into standard form? There's only one way. One easy way.
Well, I feel like I don't know.
I mean, would it be,
The x squared. because I mean,
once you
eight-
foil it out
Foil
and then add 1 on the end?
That's all you gotta do. You have to actually just multiply it out. So you would take x minus 2 squared, I'm sorry, I just wrote that again. X minus 2 times x minus 2 plus 1. Now, for those of you in my Algebra 2 class, which is 2 of you, do you remember the shortcut?
You don't have to do the middle, or something like that?
No, you still gotta do the middle, because that's what you, when you're doing conjugates.
Oh,
But do you remember the shortcut for squaring?
nope.
Okay, here you go. I'll do it one more time. X minus 2 squared. Okay, here's the shortcut. It only works for squaring. All right? So, what's x squared?
X squared.
Oh, very good. What's negative 2 squared?
4.
Plus 4. What are these two multiplied together? What's negative 2 times x?
2x.
Negative 2x, right?
Oh, yeah.
Double it.
Negative 4x.
And there's x minus 2 squared.
Okay.
If you FOIL it, you're going to get x times x, which is x squared. You're going to get x times negative 2, negative 2x, x times negative 2, there's your negative 4x, and then positive 4 plus 1. So my final answer here would be x squared, oh my heavens, that was awful. X squared minus 4x plus 5. Now, just to review, if I were to ask you to take this on and go to solve it from our previous chapter, how would I solve that? One of 3 ways solving quadratic formulas. Quadratic equations, sorry.
Factor.
Factor, does it factor?
5 and 1.
No, but they both have to be negative. So
Oh, no, never mind.
That'd be -6, yeah, it doesn't work. So since I can't factor, what do I do?
Quadratic formula?
Say it again?
Quadratic formula?
Quadratic formula or complete the square.
Yeah.
Yeah, quadratic formula will probably be fastest. And that will give you my x-intercepts, okay? Alright, so that's converting from vertex, so you just have to, just once again, you go back to your algebra and multiply that, okay? Alright, the only thing we haven't talked about is factored form, we can touch base with that on Monday, but that's pretty much it. from Lesson 23. Now, there is a Delta Math assignment.
Oh.
You do have to graph on Delta Math.
Oh, boy.
Oh, God.
Make sure you read the directions,
Lordy, lordy, lordy.
okay? All these negative reactions, I got all those on the recording.
No, because Delta Math
Oh.
graphics.
Yay, I'm so excited.
Did you see anybody?
Now when I tell your parents you cussed me in class, I have proof.